Today we're flying a Citation Ultra, and I'm going to be showing a few details of the thrust reverser system. And even though we're in a Citation Ultra, this actually applies to the entire 500 series line of citations. So it's the same thrust reverser system for the 2, the 5, the Ultra, the Encore, all of that. It's virtually identical thrust reverser systems. So if you watch the video on the rotary test, you can see that there's a pre-flight check on the rotary test for the thrust reverser system. And this video is going to be about operationally how it works and what we're looking for as we taxi out on the actual before takeoff check. And the 6 lights that we are looking at here, really 3 lights per side, will indicate arm, unlock, and deploy. The arm light shows when hydraulic pressure is reaching the control valve, so that there's a hydraulic valve that will drive the thrust reverser buckets into the deployed position, and then it'll also drive them back into the stowed position. And that arm light, when that illuminates, that shows that hydraulic pressure is reaching that valve. The unlock light is a mechanical switch that as soon as the buckets come out of the stowed positions, that unlock light will illuminate. And that will lead to the deploy light, which is when the buckets reach the fully deployed position. That's another position switch. So to keep the buckets deployed, it's hydraulic pressure that's driving them into the deployed position and holding them out there. And then to stow the buckets, there's like an over-center linkage as part of the arms that are holding the buckets onto the engine. And that over-center mechanism is what holds them in the stowed position. So one of the really critical checks that we do before takeoff is to make sure that this EMER stow system is functioning correctly. And the way that the EMER stow system works is if for some reason those buckets were to be deployed in flight, either through accidentally pulling on the lever or something shorting out, or there's being something wrong with that mechanical linkage that allows the buckets to catch wind, catch airflow running over the engine, and they come out in flight, we need to have a way to stow the buckets. And otherwise it would be really some serious drag. It would be much more significant than even an engine failure, because with an engine failure, you're losing the thrust, but you're really not gaining much drag, whereas the thrust reversers deployed in flight would be a huge amount of drag. So to have an override for that, we have the EMER stow system. And we test that before takeoff by deploying the thrust reversers and then moving the switches up into the EMER stow position. And what that switch does is it's a separate electrical circuit that will do a couple things. It will close the hydraulic bypass valve, meaning that it will pressurize the hydraulic system. So you might need to pull out a diagram of the hydraulic system to see what I'm talking about here. But it closes that bypass valve, so it creates pressure in the system. And then it will also force the control valve on the thrust reverser to move into the stowed position. So it's using hydraulic pressure to stow the bucket, and then it's also not relying on just the mechanical linkage to keep it stowed. It's actually actively using hydraulic pressure to hold it stowed. And we're going to check that before we take off.
All right, now we've got everything started up. Everything is running as normal, and we're pulled off to the run-up area here to do this demonstration. We're going to start by deploying the thrust reversers. Go ahead and deploy those. We see those paddles come up, and we get all 6 lights. Go ahead and stow them, and you don't have to do the EMER stow. We'll just stow them normally and see how they sequence back in. Now stow them one more time, or I should say deploy them one more time, and we'll see all 6 lights come out. And notice here the hydraulic press on light is illuminated on the annunciator panel. That's just an illustration of how hydraulic pressure is holding them in the deployed position. And now let's do the EMER stow feature. So we flip those switches up to EMER stow. Now notice how The arm light is still illuminated, hydraulic press is still on. Go ahead and stow the paddles. And everything still looks the same up here. The arm light is still on because hydraulic pressure is still reaching that control valve, driving the thrust reversers into the stowed position. It's not relying on the mechanical linkage. And the hydraulic press on light is illuminated. And now when we shut both of those emer stow switches back to normal, the arm light extinguishes and the hydraulic press on light extinguishes, meaning that the bypass valve is opened back up and everything is back running normally. So that's the check that we do before takeoff, is we just deploy the thrust reversers, flip the switches up into the emer stow position, make sure that the circuitry overrides the paddles the way it's supposed to, and then we can stow the paddles and flip the emer stow switches back into the normal position.